monotonically decreasing sequence. Monotonically decreasing sequence. So again, we are assuming that monotonically decreasing sequence of positive real numbers. So if it be a monotonically decreasing sequence of positive number. Suppose A is a positive integer greater than 1. Then what will happen? Then the series f of n and
हेलो
yes.
ज्वाइन तो किया होंगे
ये वैसे
Alok, what are you doing? So what do you mean by Cauchy's condensation test? So for that we need a monotonically decreasing sequence first and a positive real number positive integer greater than 1. Then both the series. So here you see infinite series everything. So I'm not writing always n equals to 1, 10, 20. Okay. So these both the series either converge or diverge together. Suppose you want to test some series, so you have to check whether, suppose you want to check convergence of this series. Suppose you know for some a greater than 1 whether this series is convergent or not. Suppose this is converged for a equals to suppose 2 to the power n, f of 2 to the power n. Then the original series will also converge. If it converges, then it will converge. If it diverges, then fn will also diverge. Okay. So suppose we have to check convergence of this series. I will check convergence or not. I will check convergence of this series. So first what you have to show? First what you have to show? First what you have to show? But first what you have to show to test Cauchy's condensation test? Not bounded below. First you have to show that this series is the sequence of n, that is sequence. What you have to show this sequence? I have written here. Monotonically decreasing sequence of positive real numbers. That you have to show first. And you have to check, you have to take one positive integer a greater than 1. Then you can show whether that can be proved or not. So first you have to show first what you have to show. First what you have to show. No one. That this sequence is monotonically decreasing. Okay, first you have to show that this sequence is monotonically decreasing. So is this sequence monotonically decreasing? Is this sequence monotonically decreasing? So here f of n is your 1 by n log n square. Is this series monotonically decreasing? Is this series monotonically decreasing?
Yes.
So how will you show it? How will you show that this I will show this? Does this hold? Does this inequality hold?
So as n is greater than 0, so basically both the values upon
N is greater than
0.
1. Here we have taken from n equals to 2 because log 1 value.
Yes, sir, yes, sir.
So that's why we have taken from n equals to 2 to infinity. Yes, what you are saying?
So, sir, as the n is greater than 1, so
Hmm.
log will be increasing function,
Yes.
and n plus 1 is also increasing.
Hmm.
And since that is in reciprocal, that will be the decreasing function.
Yes. Yeah. So we write since log x is increasing function. So first hypothesis is true that fn be a monotonically decreasing sequence. Now we have to choose a positive integer greater than 1. Then you have to check whether this one converge or not. Okay. So what you should choose as a there should be some positive integer greater than 1. So first one say equals to some positive integer greater than 1. So from where you should start?
2.
Positive, yes. So if you take 2, then what about this series? 2 to the power n, f of 2 to the power n. What will be this series? Ultimately, what will come? This series 2 to the power n 1 by 2 to the power n of 2 to the power n square, right?
Yes, sir.
So ultimately, what you will get?
1 by log 2 power n square.
So this n will come outside, right? N log 2. And this 2 to the power n, 2 to the power n cancel, right? So ultimately, you will get this is log 2 to the power n, right?
Yes, sir. We
Square.
take 1 by 4 log 2 का square.
1 by 4.
Yes, sir. नहीं, 1 by n square log 2 का square.
So you will get 1 by log 2 square, 1 by n square. So this n log n square and this series either both will converge or diverge. What about this series? This series converges or diverges?
Converges.
Why?
So 0 पे converge होगा ना.
No, why? No. Why this series converges? कैसे पता है तुमको 0 पे converge होगा?
अगर n वैल्यू ग्रेटर देन 1 है और लगातार बढ़ती ही जाएगी.
But first value is n equals to 2, right? Okay, first now you should study whether this is convergent or divergent. Then we'll later on, when you study Fourier series, you know all the summation. Not now. Okay. So just tell me whether this series converges or diverges. And you have studied some property, right? N to the power p. This series n to the power p. So this here p is 2, right? So this will always converge. This series, right? So this series will also converge. Okay.
Yes.
So this is a convergence series. So till now we have just checked if you know that you know the sequence of partial sum, so you can guess what this series will converge, right? You have to consider sequence of partial sum. Suppose Sn. Okay, first you have to see where Sn. So you limit n tends to infinity, Sn where it should go. That will be your summation of this series. Okay, but here we need only the convergence, whether this series is convergence or not. So this series will converge by Cauchy's condensation test. There are other tests also, but this mainly these 5 tests. Okay, one is first comparison test. We have studied. Then so everything for sequence of positive real numbers. Okay. Then limit form. Then D'Alembert ratio test. Then Cauchy's root test, and then Cauchy's condensation test. So for each test, we have already got some example, right? So any other doubt in series? Any series? So we'll send you tutorial for series also later on. So any other doubt for series? No doubt for series. So you have to practice. Okay.
Sir, please share the link for Google Classroom.
Oh, I'm not taking any. Everything is in Zoom, right? What you are saying?
Sir, the link for Google Classroom, the where you send the assignments and tutorials.
Okay, that I'll send later on. But everything you used to get by email, right? Only.
Yes, sir. Yes, sir. We receive emails, but matlab, I thought I have to submit the assignments there in the
Oh,
classroom.
no, not now. I'll send. I will send you email first, right? That you need to
Okay, sir.
submit, and the deadline will also be given. So, any other doubt in series? So, have you studied limit in your 12th class?
Yes,
What do
sir.
you mean?
Yes.
Yeah. So what do you mean by limit? Why you need limits? What will be your answer? Limit. Huh?
Sir, in last question, sir, please explain, sir, what you have done after taking A is equals to 2.
Okay. So what is Cauchy's condensation test? That if this sequence is monotonically decreasing and if A is a positive integer greater than 1, then both the series have the both will either converge or both will either diverge. Okay. So hypothesis is that Fn should be monotonically decreasing, and this S should be positive integer greater than 1. So here first, so we have to check convergence of this series. So that means Fn is this 1 by n log n square. And we know that this will always hold because log n is monotonically decreasing. Log x, so 1 by a log x is, so here I have written that log s is monotonically increasing function. Okay. So this n plus 1 log n plus 1 square greater than n log n square. And when you take the reverse, it will be monotonically decreasing because this is your function. So f of n plus 1 less than fn. So f of n is monotonically decreasing. So first property holds. And now we have taken a because a is a positive integer greater than 1. So you have to check whether this series converges or diverges. If it converges, then your original series will converge. If this diverges, then original series will diverge. So you are checking 2 to the power n, f of 2 to the power n. What will happen with this series? So in order to check the convergence of this series, we will check whether this series is converge or diverge. So you are checking 2 to the power n, f of 2 to the power n. So if f of n is n square, then f of 2 to the power n. So you replace n by 2 to the power n. So here we have n by in the f of n series. So here 2 to the power n, 2 to the power will cancel, and log of 2 to the power n equals to n log 2. So here will get 1 by n square, right? And log 2 is constant, will come outside of the summation. So log of 2 square into 1 by n square. And we have studied that 1 by n to the power p series converges for p equals to 2. Even for p greater than 1, we have seen. So that means this series, whole series, this series converges. By Cauchy's condensation says this series will also converge. Why Cauchy's condensation says this series will converge. Is it clear? So there are total 5 tests. There are total 5 tests. First one is comparison test. Second one is comparison test in limit form. Okay. Third one is D'Alembert ratio test. Fourth one is Cauchy's root test. And fifth one is Cauchy's condensation test. And for each test, so if in exam any specific test is not given, you can check by any one of the tests. But if it is specified, then you have to check only by that test. So have you studied limit, right? In 12th class, so what is the limit? What do we need limits?
To find the approaching value of a function.
To find the approaching value of a function. Any other answer?
To see the actual approach of the function.
Anything else or? So in 12th class, you have studied integration, right?
Yes, sir.
So how you have calculated the integration? What is the definition?
Y dot dx.
Of small areas under the curve.
Yeah, so small area under the curve, and then you are taking. So suppose you have to find the area. Suppose this one here A and B. So what you have done? You have divided the first. Suppose this is your integration A to B. This is suppose y equals to f of x. So how you have find it? What is the method actually you have studied?
First, we
What
take
is
infinitesimal area and then we integrate from A to B.
So you have divided it in small sub interval,
Rectangle.
this AB, and you'll find some tiny rectangle, right?
Yes, sir.
So there the limit will come, is not it? So their limit will come. So by limit, we can find the area of any closed curve, right? By fitting tiny rectangle, right? To approach limit. So you can use simple shape measure. So it's like simple shape measure rectangles to find the measure of this complex shape, is not it? So suppose if you know this area of this one, this tiny rectangle, and you can use it to find area of any kind of curve, is not it? So you have also studied derivative, right? So there is also limit will come, right? So finding the speed. Okay, let me write it here. Finding the speed. Suppose you want to an object is moving with some speed and you want to find the speed at an instant. Then how will do it? How will do it? Hmm? So finding the area of the closed curve by right. Suppose there is singularity on at some point. Huh? This kind of function, right? So how this function behaves, whatever you are saying just now, right? These kind of things you are saying, right? Whatever is happening near x equals to 1, that you are just trying to say, right? So it has various approach. So one is finding the speed at instant. I will do it. I will do it. Finding the speed at instant. Suppose with respect to time it varies. Like so, suppose your f of t some a t square. Huh? So how will be? So we have to check right? There in the denominator. There in the denominator, like it will come like suppose your what you have put small change some. So what is the instant speed? Suppose point. So suppose here h you cannot take 0, right? Instead, what you have to do? You have to take a smaller and smaller number, right? And you have to see what is happening. Is not it? So you have seen various examples, right? So what we should write here that how to predict a value of a function, right? How to predict a value of a function at a point. So suppose here point is x equals to 1 in this example, which may or may not be in its domain. Is it clear why you need limits? What is limit then? So you have to analyze by nearby points, right? Suppose this is your function. So suppose now you want to see the value of f at x equals to 1, predicting value at x equals to 1 by analyzing its values at points near x equals to 1, right? So for that, you have already studied sequence, right? So suppose you have to find what is happening nearby x equals to 1 point. Okay. So suppose an and an should be not equals to converges to x equals to 1. Okay. So you want to predict the value at x equals to 1. For that, you have taken any arbitrary sequence where n is not equals to 1 that converges to x equals to 1. Okay. Now what you should check? What you should check? What is happening with this sequence, where it goes. Okay. So where it goes, you have to check. And that will be your limit at that point. So in this example, your f of an is for any sequence an, f of n is what? In this example, what will be your f of an? So n is any sequence where n not equals to 1 converges to 1. N is any sequence which converges to 1, because at one point you have to predict the value by analyzing its nearby points. We have considered one sequence that converges. Now you are checking what is happening with the sequence f of an. So f of an is what sequence? This one. F of n goes where f of n goes. While f of n goes, this goes to 3, right? Because n goes to 1, is not it? So as you approach x to 1, your f of x should approach to 3. Is it clear? So when we approach x, so you are predicting the value, it should be natural value should be x equals f of x should be 3. Is it clear? Later on, we will say in the continuity that whatever you are predicting nearby values, that should be equals to the value at that point. Then in that case, the function is said to be continuous. That you already know, right? Limit continuity already know or not? So is it clear? So we don't care what is happening at that point. Okay. Till now it is clear. Till now it is clear or not? So why you need
Yes,
to
sir.
find, yeah, so finding the speed of instant you have seen here, right? Because you cannot take here is 0, right? So you have to take a smaller and smaller and you have to check what is happening. Similarly, here also when you find the area of any kind of curve, what you used to do? You used to do only divide it into a small tiny rectangle, and then you have to take as this number of rectangles to infinity, what is happening. That means this step length, small step length should goes to 0. Okay, number of rectangle goes to infinity. That means this small, when you divide this AB interval into small sub interval, the length of that sub interval should goes to 0, and that is, you have seen that denoted as h, this small length of sub interval here. Similarly, here also you have seen that if there is some single, what is happening behavior for around x equals to 1. Here we have seen one example using sequence, okay, because you have studied sequence. So this is one of the definition for limit. You know, when you want to find the limit of a function at some point, what is happening nearby, you have to check any sequence that converges to that value where you want to check the limit. So what will be the corresponding f of a n sequence value goes to? That will be your limit at that point. Suppose we take f of x equals to box x function that you already know, right? These functions. So suppose we want to see what is happening at x equals to 1, how the limit behaves at x equals to 1. So what will be your answer? So can we predict? And you know that limit, the value of the limit at some point should be unique if it exists. If it exists, the value of the limit at some point should be unique. Okay, in the case of sequence also you have seen it. So can we predict value at x equals to 1? What will be your answer?
1. 1.
Exist.
Exist, right? So you are not caring what is happening at x equals to 1. What is happening nearby point x equals to 1, that you have to check. Is equals to what is happening at x equals to 1, then getting some extra, that is continuity, that will come later. But from the limit, we are not caring what is happening at x equals to 1, but what is happening nearby x equals to 1. So is this, so predict a single value?
No, sir.
LHL not equal to RH.
So kind of sequence, suppose what kind of sequence you should consider? Some sequence which converges to tell me, some sequence which converges to, so limit does not exist here, right? And since this is a box, what you should consider? Suppose an you are considering, just give one an of n goes, then you have another sequence n such that f of should goes to certain value. Then means your prediction a single value, right? That means the limit does not exist. Can you give some two sequence which converges to 1, but can we give some n which converges to 1? Two sequence, but their this sequence should goes to different. Okay. Suppose A and we have choose. Both should converge to 1. But this should suppose goes to 0 and this should 1. Can you give some example? You can think, right? Suppose here 1 is there. So if you take little bit small value than 1, then what will be your box X function? Huh? Whatever you have that you have to apply here. Then in the next class we will see what is meant by epsilon delta definition. So first, since we have studied sequence, that's why I am now using the sequential approach. So can you give some example of the sequence such that n goes to 1 but f of n goes to 0 for this function at x goes to 1? Can you give some sequence? So what kind of sequence you have to choose such that f of n should goes to 0? That you can see, right? That means you have to see some, what you have to do? So 1 minus some values, right? Suppose 1, this sequence. And suppose Bn is your 1, this sequence. So is where is this sequence goes? 1 minus 1 by 3n that you have studied, right? 1 minus 1 by 3n. Where it should goes, this sequence? This sequence goes to where it should goes. This already have studied, right? In sequence. 1 minus 1 by 3n. Where this goes? This sequence? No one? Where the sequence goes?
Repeat, sir.
Yeah, first tell me where this sequence goes. Where this sequence converges. 1 minus 1 by 3n.
1.
What this sequence converges? 1 plus 1 plus 3n. 1 plus 1 by 3n. Where this sequence converges?
1. Same, sir.
So both sequence converges to 1. Is it clear or not first? Both sequence converges to 1.
Yes, sir.
So we have taken two sequence, both sequence converges to 1. Because we have to find what is behavior at x equals to 1. That means we have considered two sequence which converges to 1. Now we have to see what is happening with f of a n sequence, right? So when you choose f of a n equals to 1 minus 3n, so f of a n is box of 1 minus 1 by 3n. This sequence goes 0, right? So that's why I've written 0. And where it should goes? 1, right? So we have find two sequence which goes to 1, goes to different. You cannot predict a single value at x equals to 1, right? Is not it? Is it?
Yes, sir.
So consider any sequence, okay, which converges some value where you have to find the limit, okay? So should I write the definition here, right? In the sequential criteria. Then we'll see that your epsilon delta definition that you have seen, right, already. So f is a function from this open interval to R. Say that F has a limit point at C belongs to I. If what I should write, the limit so the limit means if there is a, I should write real number. If there is a real number L, such that what should happen? Should happen any such that for any sequence Cn not equals to C. For any sequence Cn, if Cn converges to C, what it that f of Cn would converges to L. So okay, unique, and this definition, these examples above this violates this definition, right? You have chosen two sequence An and Bn which converges to C. Here in the above example, C is 1. But f of Cn, in one case L is 0, in another case L is 1. That cannot happen, right? So L should be unique. Is it clear? So suppose your limit does not exist. So this is known as limit extends to C f of x. Okay. Now in the case of continuity later on, we'll see whether this value is equals to your f of C or not. That we'll see later on, not now. In the case of limit, we don't care what is happening exactly at C with whether this values is equals to f of C or not. In the case of limit, we don't care. So one example you have seen, right? The limit x does not exist. So you have considered two sequence which converges to 1, but their functional values goes to different limit. Okay. So suppose you have to show the limit extends to C, f of x does not exist. What does that mean? What you have to show? It is enough to show that we have to show. Suppose we have to show that limit does not exist. That means what you have to show? I just wrote it above.
Two
What you have
different
to
values in the neighborhood of x.
So you have to consider two different sequence, right? Which converges to C. Okay, but that you have to show, right? Is not it? This one is there. Another one, suppose the sequence is divergent. That means Cn converges to C, but f of Cn divergent. Okay, if you can show two sequence, if you so here you have to choose some particular sequence. Okay, some particular sequence Cn converges, but f of Cn divergent. That means the limit does not exist. Is it clear? Is it clear? So till now any doubt? Till now any doubt? In the next class, we will see what do you mean by that epsilon delta definition. But since you have studied first sequence, so I am using here the sequential definition for limit. So till now any doubt? So similarly, this algebra property of limits will also hold. Huh? What do you mean by that? Suppose this limit extends to C f. These are exist. Huh? Then what will happen? Whatever you have a plus minus gx will equals to limit extends to C. Okay. Similarly, for the limit extends to C, f of gx will be equals to similarly other properties will hold. Huh? So for any real number is any limit extends to C. This suppose this alpha. Similarly for division, but in the case of division, the denominator should not equals to 0. Limit extends to C, g of x not equals to 0. In the case of sequence also you have seen, right? That then limit extends to C, if f by g x will be limit extends to C, f of x. So using you can find various limits. Okay. Suppose f of x equals to 1 by x. X not equals to 0. Okay. So at x equals to 0, the limit exists. Huh?
No, sir.
Why? Why? At x equals to 0, this limit does not exist. Why?
Because it is not finite variable.
Fix is not defined.
We don't care x equals to find or not, huh? Okay. But why it is not, limit does not exist as x equals to 0? Till now, whatever we have studied using,
before 1 and after 1.
What?
Different values will come for less than 1 and greater than 1.
Yeah, so suppose we have studied sequence, right? So using sequence, how will say? I have already written, right? Is not it? This one I have written. Huh? Why it is process? Cn tends to C, so but f of Cn is divergent. Can you use this one? What Cn you have to choose here? What Cn you have to choose here? You have to check what is happening, right? How will see you? What sequence you have to choose? That at least you should tell. What sequence you have to choose? So you have to check at 0, right? So that means C is your. That means C is your. So you are checking whether if this limit does not exist, then have to show that one sequence converges to C, but its value is divergent. So can you choose some sequence? It's very easy. So what you have to choose? Some sequence Cn converges to 0. You have to check the limit at 0, right? What is happening? But f of Cn is divergent. Can you give one example? Can you give one example here? Can you give one example? Okay, so we continue in the next class. Check. It's very easy. Okay. See you on Monday.
Thank you, sir.
It's very easy. You should tell. Okay, see you.
Recording stopped.